Good morning, good afternoon, good evening. Take my greetings according to your timing. Me, Ayushi Sarkar of third year ECE, will be continuing with the second lecture of Signal and System. So, I just want to give you a short recap what we have studied in our last lecture. Obviously, the introductory ones. There, we have already covered some few parts. We had the syllabus discussion, and after that, just basic terminologies: what is signal, what is system, what is continuous time signal, what is discrete time signal, and obviously the importance of signal and system in our day-to-day life. So after that, we have studied how we can do addition of CTS and multiplication of CTS. That's all. And here we are going to learn three basic things of signal and system. So I will be teaching you with the continuous time signal. And after that, I will be teaching you with discrete time signal if you need it. If you comment, then only I will go for it. Else, I will be continuing with the continuous time signal because discrete time signals are not overall so much important. If needed, I will be covering it. It's like after completing the syllabus for sure. So here we are going to learn what transformation. So there, if I will tell you one thing, there are signals. There are different types of signals. So if I will tell you about different types of signals, there are continuous signal. There are different types of discrete signal as well. So let me add a page over here to make you guys learn one thing. Okay, chalo. So here I want to tell you that signal has some basic properties. And through this, we can do some transformations as well. So here you can see when we will be doing any kind of transformation. So these transformations are what? They are basically shifting of a means like there are three types of transformation. Let it be clear. One is scaling. Scaling is what? Scaling is basically multiplication. Okay, it's multiplication. Shifting is what? Shifting. Shifting told you about addition. And reversal is what? Reversal is also a multiplication, but minus one multiplication. Okay. So this is nothing, just a means like overall idea about it, just nothing much. So let me figure out with the main sort of thing. Chalo. So let me take you to the main slides. I hope the slide is clear for you. So here we'll be studying scaling. So scaling, when we are talking about the time scaling, we are basically talking about the compression and expansion. What is compression and expansion of a time signal? When I will be taking example, I think you will understand it better. So just remember the word compression and expansion of a time signal in accordance with time. This is the main word, in accordance with time. Okay, so remember this word, mark this word, time. Why time? This is our means like first signal xt. Okay, when we are going to multiply anything, means like let's say we are multiplying a constant alpha with the time. Okay, then only it would be termed as time scaling. Okay, see here when we are telling about xt transferring into gt, then it is converting into x alpha t. What is gt? Gt is basically x alpha t. This alpha over here is getting multiplied with xt, and then it is giving you alpha t. Remember this term, and you will be happy to learn that we are having two configurations from here. One is compression, another one is expansion. So what is compression? Basically, what do we understand by the word compression? Compression means like getting something reduced to its shape due to some pressure. So here you can see that with alpha value is more than 1, then basically alpha is going to be what? It would be belonging to minus infinity to minus 1 and 1 to infinity. We are taking mod. Just remember this, okay? Take this in mind. Just take this note, some things that are going to be very important for you as well. So here you can see this. So from the next like example, you will be seeing that we are taking only the means like terms that are not in fractions or in decimals. We are taking just normal integers over here as modulus. So after doing so, we're taking a certain signal with a certain amplitude of 2, okay? And here t is 2. This 2 is seconds, okay? This 2 is seconds. This time is seconds, okay? And xt denotes what? Xt in y is basically the first initial signal that we are going to take. This is our initial signal, okay? And when we are using alpha is equals to 2, that means we are going to multiply xt with 2. Okay, where we are multiplying this with t, not with x. We are multiplying this with time. See, the x is not changing because it is the independent axis. Okay, the xt is getting changed into x2t, which is the dependent y axis is getting changed. Okay, how we will determine the new signal when xt is getting changed to x2t? Let me tell you how. So, just you do have to do nothing, you have to take some notes. See, here you can see this is t is equals to 0, right? Here you can see, if not clear, I'm going to take a dipper pen. Okay, I think now it would be clear. So this is our t is equals to 0. So when t is equals to 0, then we are initially doing what? We are just have to put over here the value of t. Okay, for that we will just write x into 2 into 0. Okay, that is going to be our, see what is the value of here? This is 2. Okay, x0. So what is x0? X0 is basically 2. So the value is going to be 2. Okay, then we are going to take t is equals to 1. For t is equals to 1, the value over here is changing x2 into 1. That means x is equals to 2. That is also 2 over here. Okay, so initially what we can conclude from here? We can conclude that basically x2t is equals to 2. Okay, we can conclude this very easily. So after this, we can have a shortcut from here. If you need example, I can go for it. But otherwise, I would be moving with the second case. So this is the case of compression. And when we will be plotting it, we will be plotting it like this way. Like t is equals to 1. Okay, t is equals to 1 over here. Okay, and then the amplitude is not getting changed. 2 is going to be constant. And then the new signal is going to be our compression. Initially, it was like that. Initially, it was here where the 2 lies. Okay, but it changed over here. So let me move on to the shortcut. And after explaining you the shortcut, then only I will be moving with the next case 2, so that you can solve this case 2 using the shortcut as well. Chalo, let me tell you how the shortcut is being used over here. So see, here is x2t is equals to 2. Okay, so x2t is equals to 2, and here let's say 0, t and 1. Okay, how we are denoting this? I'm telling you very simply, we have to think about those things that where the t is basically lying. Okay, so if we get something like 0, t and 1, we have to be having these things. So let's say 0, t, 1 is there, and then we are moving with 0, 2t and 2 in this configuration. And what we have to do, we have to just divide it with alpha. What is alpha? You know, the multiplication term is alpha. So firstly, we have to think this very clearly that in time scaling, amplitude is gonna be same always. Okay, always remember, amplitude is never going to change in case of time scaling. Okay, and one thing next is that divide the time slots with alpha. Okay, so that you can get the new signal. I think it is completely clear to all of you. Let me move to the next plot. So the next plot is expansion. So before moving to the expansion, I just want to tell you one thing. Once we have learned the shortcut, I would be using this shortcut trick to make you learn how the expansion is taking place. And once again, I'm telling modulus of alpha should be less than 1. Okay. But if it is less than 1, then remember alpha is not equals to 0. And this time we are taking the decimal figures 0 0.1, 0 0.5, and etc. Okay. I think it's clear for you. So let me and this is one of the main point. I think a belongs to -1 to 0 and union 0 to 1. Okay, so after this I would be using here what I would be using the shortcut trick. Let me take you to the shortcut trick. So here I am taking alpha as 0.5. Okay, so if I'm taking alpha as 0.5, so what we have learned initially, we have learned that we have to write the timings. Okay, so what are the timings? Timings is over here 0.5t. Okay, because we have to learn from where it is starting, so we are writing 0.5t. Okay, you can see that I have already written over here, but to explain you guys I am writing it again. So 0.5t, alpha is our 0.5. Okay, so basically we are getting t. Okay, then we are having 2 from where this is the 2, we need this as well, 2 by 0.5. Okay, it is giving me 4. The point where the signal is ending over here, now it will expand to the point 4. Okay, here the expansion takes place. This is the main point. And then again, you have to do what? This 0, we are going to take 0 by 0.5. Okay, is going to be 0. So clearly you can see one thing, that the signal is not going to change, just it's going to be expanded. Okay, so from here you can say that how the plotting will be done. So it's very simple. See, this is our initial plot. Okay, let me take this. Okay, this is our initial plot. Okay, and once we plot this initially, and when we are multiplying, just once we get this point, this is the main point, 2 by 0.5 is equals to 4. Okay, then only we can go for this. And if you want me to solve like the normal traditional way, that also I can do for you. Let me solve it like that as well. This is the short trick I have used. Let me solve for the traditional way. So for traditional way I'm taking, wait, just a sec. Okay, t is equals to 0. Okay, for expansion. So here we are going to do what? X 0 into 0.5. Okay, that means x0. X0 is already 2. Okay, then again t is equals to, I am going to take here 1. If I will take 1, okay, I don't have any problem with 1. Let me take 1. It's 0.5 into 1. Okay, that is going to be x 0.5. That is also 2. And when x is equals to our 2, just I need to rub it, okay, so that I can get the main sort of thing. X is equals to 0.5 multiplied by 2. What's going to be this? This is going to be our 1. Okay. And once you get x1 is equals to what? This is also 2. Okay. And here, once you get x 0.5 into 4, we are getting what? We are getting 2. X2 is going to be our 2. So here you can completely see that for different sort of points, we are getting different sort of values where we are judging it. But simply I want to say you that once you get the value for this, we are just going to multiply it, and just we are going to put the values over here. It's going to be simple and quite easy for you. Don't go for the traditional method. So you can see here what's the problem was. Traditionally you couldn't even find the point for where it will be extended. Okay, so traditionally it's going to be very difficult. You can just use the shortcut and just move for the transformation. Okay, So let me take you to the next sort of thing. Next is our amplitude scaling. So in our amplitude scaling, what are we going to learn? We are going to learn that here the amplitude changes. This time we will be multiplying a constant that is called as beta with the direct amplitude. Okay. So xt is our initial signal. Okay. And this yt is going to be our final signal. So what is this final signal? This is just the multiplication of beta with the amplitude. So in this case as well, we will be taking one thing. Case 1, beta is greater than 1. When we are taking beta as greater than 1, simply we can say that beta is not equals to 0 as usual, and this is completely going to be not 0 0.1, 0 0.2, 0 0.5 and all. Okay, so this is the point. So let me take you to the main means like example. So this time when I'm taking here 2, okay, so 2 is our amplitude. Okay, and this is our time at time 2. Okay, so this time the change will be in y-axis. Okay, this time the changes will be in y-axis. Last time we were seeing that the changes are going to be in x-axis, but this time we will see that the changes are going to be in y-axis as well. So here, when we are going to find this traditional sort of thing, traditionally we do what? Traditionally we exactly do the same way how it was done in time scaling. So let me figure it out how we do it. Xt is equals to 0, 2 and 0. Okay. So at when it is 0, when the t is less than 0. Okay. You can't see anything. Okay. And then when it is 2, over here you can see this is 2. For which term? When the t lies between 0 to 2. After that, it is again 0. Okay. So after this, you can say that how the plotting will be done. Okay. So this is the overall sort of thing. And when we are just multiplying it, okay, when we are multiplying this to xt, the change is where the change is there in the y-axis. The multiplication changes. So here you can say that when we are multiplying basically and the things are getting changed, we need to learn one more thing. When we are applying this as our basic concept, we can use one more step over here. So firstly, we will do what? We will just multiply this. Here you can see that this is the normal sort of thing. Then when we are multiplying this 2 with the yt, so what is yt? We just have to multiply everything over here. Means like when we are doing yt, what is yt? I'm telling that when you're going to get the final signal yt, you're just going to multiply the amplitude with 2. Nothing more than that. So how will you do this? Just simply you will multiply 0 into 2 for time interval t less than 0. And here you will multiply 2 into 2, that is going to be giving you 4, and here it is 0. Okay. So the time intervals are going to be same. Don't change anything with time. You have to change this time. You have to play this time with the amplitude, not the time. Okay. So after this, you will have to multiply 0 into 2. This is again going to be 0 when t is more than 2. Okay. So after getting all this amplitude of the final signal, you will have to just simply plot it over here. You can see the 4 is here, 2 is here. You will plot this simply. Okay. So you can see this time the amplitude is getting increased. So when the amplitude is getting increased, what is happening? So once you can see that there is amplification. So generally, when you can see the change in amplitude, the change is in upper side. Okay, we generally termed it as amplification. In case 1, where the beta is greater than 1, we call it as amplification. Okay, so after this we are moving to case 2. So what is the case 2? Case 2 is generally like the case 2 of the time scaling. Here the beta is less than 1. Okay. So what is less than 1? Modulus of beta is less than 1. That means we are going to take this time beta is equals to 0 0.1, 0 0.5, 0 0.2 and all. Okay. So this time we are doing same thing. Okay. Here we are taking xt. Let me write this directly. Okay, this xt is going to be same. Okay, let's do the xt remains same for this initial signal. Okay, because I have used the same signal. Okay, so when I'm going to calculate the yt, okay, so what is the yt? Just you have to do nothing, we have to multiply this. How will you multiply this? You will just have to write here 0 multiplied with 0.5. This time we are taking beta as 0.5. Okay, and 2 into 0.5. Okay, and here you can see 0 into 0.5. Here we are getting 1, here we are getting as 0, here we are getting as 0. Okay, so here one thing, the time intervals are going to be same. Again, I'm copying from here, copy, paste this time intervals over here, paste. Okay, I think you're clear. So how will you plot it? Plotting is very easy. For t less than 0, we are going to have what? We are going to have uh, 0. Okay. When t is equals to 0 and lies between 2, it will be 1. The amplification over here is just reduced. This reduction is taking place when beta is less than 1. Please, 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 again I am telling you, please take the notes. There is a use of modulus. Okay, here the reduction is taking place. Here the reduction is taking place. I hope it is clear, nothing much to know about it. So moving to the next sort of transformation, that is shifting. If you are clear with this scaling now, then you can easily grab the reversal. Let me take you to the reversal first, then I will be teaching you with the shifting. Okay, so let me take you to the reversal. Okay, so this reversal is basically a special case of scaling, where you are going to use this alpha as minus 1 in case of time scaling, and beta is equals to minus 1. Okay, this is just reversal. So in case of time reversal, we called it as folding or reflection. Okay, and in case of amplitude reversal, we are just going to take this minus 1. This is also called as folding and reflection. How you are doing it? You can write this equation very easily. I'm not going for any kind of equation and all. I'm just going to teach you what's here. So what you can see, this signal and this signal is kind of a mirror image, right? So if you will take the mirror image along with y-axis, means like, see, wait, let me do one thing. This is the mirror. Okay. How will you plot this mirror image? Let me select this. Okay. Let me select this part. Okay. This is the just mirror image. Just try to see this. I think you are getting, right? This is transferring like this way. This was the initial signal, and when we are going to take this, we are just not going to, just we are shifting it over here. How this cursor is moving, just look at that. Okay, so initially this is the whole sort of game. Here the reflection is taken accordance with the y-axis. Okay, in case of time reversal, so the basic is like norm of this is just take mirror image. Simply I'm telling, just take mirror image along the y-axis in case of time reversal. Okay, sorry, over here, see, here I have already taken mirror image along y-axis. Nothing much to make you learn, just the simple thing. Okay, I think thing is clear. And how am I doing this? Let me check you out over here. So when we are multiplying minus 1 with the t, here we are changing this xt to x minus t. Okay. When we are changing xt to x minus t, we are just doing what? Here we are taking minus t. Okay. Minus t is less than 0. Okay. 0 lies between what? 0 to 2, and it is minus t. Okay. Minus t is greater than 2. And you will you know that if I want to means like just reduce this minus from this t, we have to do what? We have to just shift this, like we have to just alternate this greater than and less than sign. We are just doing the same for this time. T, when t is greater than 0, okay, then it is going to be 0. Okay, when t is less than equal to 0 but greater than equal to minus 2, okay, we are going to get 2. Okay, and here when we are doing minus means like t is greater than 2, but here for shifting this we have to just conduct over here, this minus will come over here, and the uh, greater than sign will change to less than sign. Okay, so like this one, this is the traditional method. I would just suggest you for doing this kind of transformation, just go for this basic simple trick, that is y-axis and mirror image. Okay, I hope it is clear. And again, I'm going for this amplitude reversal. The amplitude reversal is also same, but this time you are going to take this mirror image on x-axis. Okay, you are taking this, let me draw it for you once again. This is our x-axis. I'm drawing this mirror. What you will do, just let me select this. Okay, so I'm going to take this. Okay, how it is coming, can you see? Just try to see the cursor, this red pointer. Okay, this is the way you will draw the mirror image. Okay, so this is the way how we will draw it. So here you will get the mirror image. The same way, I'm just not concluding with the thing. Just this time you have to write, see, this is our xt and this is our minus xt, nothing more with that. Just you have to multiply a minus 1 with all the amplitude, and here you will get as a negative. Okay, so simply I'm telling you one thing here, the reversal is taking place, right? So this is basically shifting. You can see, means like, sorry, I'm telling you. So when you will learn shifting, you will get to know different types of phenomena. You can see one thing. In case of scaling now, the basic thing is what? The signal is getting changed. The original waveform of the amplitude is just somehow getting missed. It is getting changed. Okay, in case of scaling. But when you will learn shifting, this is also a transformation, but this time the original waveform remains same. We will just shift that original waveform to some extent, but we are not going to like completely change that signal for amplitude shifting. Okay, so let me move to the amplitude shifting first. Sorry, time shifting and amplitude shifting, both I will make you study, so it doesn't matter even. So let me take you to the shifting part. So here, if I will make you study about time shifting, what is shifting? Shifting is basically addition or subtraction of anything. Means like a some constant. Okay, so for me, let's say this time in time shifting, the constant is k, and this k is in seconds. Okay, so when this x lies between 0, c, this is our signal. Let me take you to the signal, then I will make you understand what was the equation and everything. So here you can see I am taking the same kind of example so that you can be very much clear that what is scaling, what is shifting, and what is reversal and anything. Okay, so that when multiple transformation is going to be held, you will just means like keep everything in mind. Okay, so this is the same signal again I am taking. So you have seen over here, this time k is plus 2, positive, positive shift. So different. This is our basically left shift, left shift. Okay, left shifting. Why this is left shifting? I'm making you understand. Okay, let's say x is equals to 0. Okay, so when x is equals to 0, we are just adding 2 with that. Okay, so here x is equals to 0, then x is equals to 2, but for in case of 2, y is equals to minus 2. Why this is minus 2 over here? Because here it is already, means like you are taking this initial plus 2. Okay, you are moving forward. Let's see if this is not practically possible, but let me take you an example of bomb. Okay, see, this is a bomb. Okay, this is a bomb. It has a timer of 10 minutes. Okay, this is a 10 minutes timer. So this is our wire. Okay, this is our wire. This is our blue wires, and this is our Purpleware. Okay. Let's say this purpleware is something. If you cut this bomb, means like cut this wire, the bomb will explode like on that moment. And let's say it's 8-10 minutes left in the clock to explode, but you cut this. Okay. And once you cut this, it would just explode on that second, on that moment. Okay. So what you are basically doing? You are just moving this time 10 minutes to zero. Okay, that means you are adding that time with this. That means you are just moving forward. You are just means like just moving forward to that time. You are just not taking the proper time. You are just adding some sort of time with that particular time so that the action takes place immediately. Like the same way you are just calculating over here. So this will explode at like somehow now at 8 minutes, let's say. Okay, that means this 2 minutes is earlier, right? How this 2 minutes is earlier? This 2 minutes is basically this K. Okay, where you are adding a certain time to this xt, and this is an example and a hypothetical example. Please don't judge this. Firstly, I'm telling, okay, this is a hypothetical example to make you understand. This k is this 2. Okay, for this we need to know how we are moving. So for time t is means like x is equals to 0. Okay, for time t is equals to 0, when it is 2. Okay, it started to be 2, but this is y is equals to minus 2. Why this is minus 2? Okay, let me do one thing. Let me do some mathematics with you. Okay, erase. Yt is equals to x t plus 2, right? So one thing you should be very clear is that xt is always going to be y t minus 2. Okay, this is very simple. So that what you are using over here. Okay, so when x is equals to 2, then y is equals to 0. So you got the plot where you have to plot. This is minus 2, this is minus 2, this is 0, this is 0. Okay, and the amplitude is going to be 2. Once again, I am telling amplitude is not going to change in case of time related transformations. Okay, and in related to means like amplitude related whatever transformation is happening, time is not going to change. Okay, so here you can see very clearly this is our leftward shifting is there. Just you are taking the signal and shifting it to leftwards, nothing much. Okay, in case of case 2, where k is going to be our negative. Okay, k is negative. This time I'm mentioning some things very clearly. Again, in case of scaling, please write it down or take a note. Okay, I am making you write over here. Okay, here I got some space. Listen, here take a note. In case of scaling, we take modulus, but in case of shifting, we don't. Okay, chalo. So it's very clear, I guess. So in case 2, when k is going to be negative, okay. So here you can see when k is going to be negative. This time I've taken different examples so that you are not bored completely. Okay, let me take the it's like this only. Okay, so that you can understand what is there. So here you can see a triangle is there. From where? This is from minus 2 to 2. Okay, so there is an advancement. This is the advancement. Okay, because you can see the same way I will do it for this. So here when I have written you yt is going to be our x t minus 2. Okay, then always remember xt is going to be what? Y t plus 2. Simple, easy peasy. Okay, so let me take you from here minus 202. Okay, so x, let's say minus 2. X minus 2 is there. Okay, you can see you just put in this equation where xt is equals to yt plus 2. When t plus 2 is there, you are just going to write y is equals to what? Y is equals to 0. That is going to be what? Amplitude is going to be changed. It's not going to be changed. So the amplitude remains constant over here. So the amplitude here is 3 and it would be 3 forever. Okay, actually it is a initially growing. Okay, so I am not writing what is the amplitude, so please bear with me with the amplitude because this is a continuous time signal. This is not a particular point. For 2, I can write, not for like this point. Y is equals to 0. It's just actually amplitude is 0. This is 0. Okay. Because this is 0 in this case as well. So x is equals to 0 this time. X is equals to 0. Then what would be y? Y is an advancement 0 plus 2. So y is equals to 2. Here comes. So here you can see at y is equals to 2, the amplitude is 3. So the amplitude remains same. The amplitude is 3. And here when x is equals to 2, then y is equals to 4. Where is this 4? This is the 4. And then again, the amplitude breaks to 0. So you can see over here, this is the complete note. Okay. So here you can see the advancement of the signal takes place. Basically, this is not possible. This is means like real life example. Only I can give it for like this signal means like bomb example was actually hypothetical. I don't know. Actually, I don't know that is there any real time advancement is not even possible. Okay. So we can't do this. We can do the delay, but advancement of signal is literally impossible right now. So you can see this is actually right shifting. This was left shifting and this was right shifting. This is our right shifting, right shift. Okay. Chalo. So last thing, amplitude shifting. After amplitude shifting, I would be moving with one priority order. Okay. Then I would be just wrapping up the session for today. So amplitude shifting, here you have to just add k with the amplitude directly. Okay. So let me take this positive. Okay. When k is positive plus 2. Okay. This xt is 0 to 0. Okay. The positive is there. So the amplitude changes to yt is going to be 2, 4, and 2. Okay. So how the changes is done? See, the plotting is the main game here. Okay. You can find it out very easily. Okay. The way I have taught you, you can find it out. Formulas like the scaling I have taught you, I think you can find it out for this very easily. So plotting is the main game here. When k is equals to plus 2, the timings are going to be same. Just the thing is what you will plot how you are going to plot. See, when t is less than 0, t is less than 0. Okay. Still the amplitude is going to be 2. So you can't initially start from here, 0. You have to start the signal from here. Okay. So you are starting the signal from here. And when you will move to t is equals to 0 and less than 2. Okay. So there you will see the sorry, I need to erase one thing. Okay, wait. Okay. So less than 2. So you can see the amplitude will move to 4. Then again, the downward shifting takes place when t is greater than 2. Okay, when t becomes certainly greater than 2, you will just move downwards. Okay, but the downwards doesn't mean you will move this till here. You have to be over here because the amplitude still is 2. I hope it is clear. See, once you learn scaling, it would not be difficult to learn shifting and all because almost all the properties and everything are means like more or less same. Okay, so initially it would be difficult. Otherwise, once you learn one topic and then you can easily do it by yourself. So let me take you to the negative. Okay, when k is less than 0, k is negative over here. Okay, this time minus 2. Let's say minus 2. So xt minus 2, this time minus 2. When this is going to be, see xt, I think you are getting right. Here, this is 0. Okay, then 0 when t is less than 0. Xt values. This is the xt values. This is the xt values for second case as well. So I'm not writing it over here because space is not there. So you have to do what? Minus 2. Here 0 is there, 0 minus 2 comes here, minus 2, 0 minus 2, then minus 2, okay. So 2 minus 2, that is going to be 0, and again 0 is there, then minus 2, that is going to be our minus 2. So how will you plot it? The plotting is like this way. See, here you have to start when t is less than 0, you have to start from the minus 2, okay. Then you will move upward to 0 till when t is equals to 0 and initially equals to 2. Okay, sorry, I think this is the, sorry, this is the thing, sorry. Okay, till when t is equals to 2, and once t is showing this shift till 1, then you are shifting over here. Okay, so here once you can see there is shifting, this is again minus 2. So the point is what? You have to start from minus 2, you will end to minus 2 because the amplitude is minus 2. Okay, this is the shifting. So I think this is very easy. For means like you can take your own example, you can do whatever you want to do. So I think I should move to one like very small topic that is left, that is multiple transformation. And I think this is very easy and very clear to make you learn the bigger thing. So for multiple transformation, you have to keep one priority order in mind. Okay, the priority order I am writing it for you. So let me take multiple transformation of continuous time signal. Multiple. Take the notes, please. See, why I'm giving you priority order. You can follow this priority order, else you have to be very conceptually strong to deal with multiple transformation. When you can see shifting, reversal, and scaling in a single like signal, you will get confused very easily. But for that, I think you can do means like you can just follow this priority order, right? So I'm just giving you this priority order. The priority order is basically, firstly you will have to follow what? You will have to follow time reversal. If time reversal is there, do it first. Okay, and then time shifting. Okay, then do time scaling. And you will say, why are you not writing the amplitude sort of thing? Okay, so firstly do all amplitude sort of thing, then only move to this. Okay, so first do amplitude. This before this do all amplitude sort of thing. Not spelling, sorry. So first priority is amplitude transformation, then this is the priority order. Okay, this is the priority order. So let me take you to the, let me give you an example. Let's say initially I am having a signal that is, let's say our basic signal. Let's take the one of our lovely basic signal xt. Okay, our favorite xt. Example xt. Okay, so xt is our basic signal. So when we are taking xt and we want a yt that is equals to, let's say we are so let's take this yt. Okay, so this yt is already I have written kxt minus t naught by alpha. Okay, so step one. Over here in step one, you can see k is our amplitude. Okay, in step one we will do this amplitude. We will sort this amplitude out. Okay, for this reason we will do what? We will just multiply k with our xt. Okay, amplitude is getting solved, amplitude scaling done. Okay, scaling sorted. Then next step, step 2. Step 2, what is there? After sorting amplitude, I have told you the priority order, that is time reversal. So you can see time reversal minus t. Okay, you have to write what? K x minus t. Okay, once you are done with this minus t, you are done. Okay, so this is our time reversal sorted. One by one step you have to do. Okay, then step 3. Step 3 is what? Step 3 is our after shift, means like after you will do this reversal, you will be moving to the shifting. You can see over here minus t naught is there. What is this minus t naught? This minus t naught is nothing but this is actually right shift. Okay, right shifting as advancement, which is basically not possible. I'm just written. Okay, right shifting is there. And for that, you will write what? K x minus t naught. Okay, so you are shorted with what? Time shifting. You are shorted. Okay, so after this, step 4, last and final one, this alpha. This alpha is basically what? This is our scaling part. Okay, the scaling part is actually on God. Three means one amplitude scaling, next time reversal, and shifting. And let me like okay. So till this third step, we have seen already amplitude scaling, time reversal, time shifting. Let me now deal you the last and final alpha. Okay, my last multiple transformation. That is our time scaling. So this is basically time scaling. How will you get to know that this is a time scaling? So once I have taught you this pretty useful shortcut over here, see this pretty beautiful shortcut here, this shortcut, you can analyze that this is a property of time scaling. So once you get it, you have to do nothing. You have to just write it like x minus t naught divided by alpha. And here you finally go with your beautiful yt. This is what we needed, right? So we are done. This is our last step. This is our time scaling. I hope you are clear with the priority order how you have to use. So after this, I'm just binding up today's lecture. Might be some faults are there from my end as well. So please let me know where you think that I also need to develop my teaching and how I can be better in next lecture. So till then, like keep on studying, keep on making your signal system notes. You can also send me your notes for recheck and everything. Try to solve more questions regarding this kind of transformation. I'll be taking a doubt clearing where you can join me, where you can ask me your doubts, and even you can go through like the questions that I'm going to make you solve over there. So till then, tada, bye bye. Let's meet you on the third lecture.